Assalamualaikum and hello to everyone. We are from Group 11 and we will discuss about the written assignment. Our group members are NURFATEMA binti NORDIN, Nur IFFAH AQILLAH binti S. MAIKEL, Nur AIDA ASYHARINA binti MOHAMMAD INDRAJAYA POETRA, and Nur Laily binti ZAHAFIAN. Let's go.
Hi, my name is Nurul binti Nordin and I'm gonna start the presentation. So this is the information that was given to us. I'm just gonna read it. Figure below shows the beginning of the DNA sequence of a hypothetical gene XYZ. The underlying sequence position 20 to 54 represents the promoter for the gene, and the underlying and its sequence position 71 to 90 encodes the ribosome binding site, which is the RBS. Transcription begins at and includes the T or A base pair at position 60, which is the bold color one. So next we're gonna jump to the first question, which is question A. Question A asks us to identify which of these are the coding and non-coding strand. So for the coding strand, which is also called as non-template strand in the diagram, is the strand that runs from 5 to 3 direction. So it is actually the first line. And as for the non-coding strand, which is also called as template strand, is the strand that runs from the direction 3 to 5, which is in the diagram, it is in the second line. So now we're going to go to question B. It is stated in question B that in the DNA strand, we can identify several open reading frames ORF in the gene. So it asks us to define ORF. So ORF, or known as open reading frames, are part of the genomes which have sequences of bases that have the potential to encode a protein. So it is a length of the NA or RNA that will transcribe to RNA, where the ribosomes will move to add one amino acid after another, starting with a start codon, which is AUG, and it ends with a stop codon, which is UAG, UAA, and UGA, which will not encode for any protein. So now we will move to the next question, which is question C.
Moving on to the next question, question C. Using your own words, explain what you understand with ribosome binding site. Ribosome binding site, or RBS, also known as strand-organo sequence, or in the short form, SD sequence. A typical RBS sequence in prokaryotes is located at about 6 nucleotides upstream of a start codon in a mRNA transcript. RBS is a part of mRNA sequence which ribosome can bind and initiate the translation. Translation is the protein synthesis process by which mRNA get translated into proteins. Next question, question D. What are the first 6 nucleotides of the mRNA from gene XYZ in 5' to 3' direction? The answer is 5' UCG GCA 3'. The question is, how can we get this answer? So firstly, we need to identify which one is the template strand and non-template strand. Based on the answer from question A, we know that the first line is the non-template strand and the second line is the template strand. As mentioned on the statement, the transcription begins at position 60. If we take a look at the first 6 nucleotides on the position 60 at the template strand, it starts with 3' AGC CGT 5'. Therefore, the mRNA sequence is complement to the nucleotides, which give the answer 5' UCG GCA 3'. That's all.
Hello, my name is Nurul and I will talk about this question. The question sounds, what are the first 4 amino acids encoded by gene XYZ? The codon table is provided in appendix. Use 3-letter amino acid code. So here's the appendix for the codon table. And as the question said that the transcription occurs at position 60. So this is the mRNA template strain that is not undergo transcription yet. And as the transcription start at position 60, which is here. So we read the base from 3N to 5N, which it is a template strand of DNA. So we start from the base A and so on, where the transcription occurs where the base A turn to U, G to C, and C to G, C to G, G to C, T to A, and so on. So from the mRNA that already transcribed here, we can form an amino acids, which is polypeptide chains that we need to choose 3 bases here. Okay, so the first base is U, the second one is C, and the third one is G. So these 3 bases will form serine, how can we know these bases will form serine? So we can refer to this appendix. So look at this first base, which is U. So here is the first base U, and the second base is C. So here is the second base. So we move to this column C, and the third base is G. We need to look at this row. So UCG will form serine. Here, serine. So move on to the second base. The second group of bases that will form alanine. So how we know that these bases form an alanine? So based on this appendix table, which is GCA. The basis is GCA. So the first base is G. The first base is G is here. We see the first basis, and the first letter is G. And the second base is C. This is the second base is C. We move to this column C. And the third base is A. We look at this row A. GCA will form alanine. So here's GCA, alanine. Move on to the third group of bases, ACU. First base is A, second base is C, move to this column. The third base is U, look at this row. So ACU will form threonine. And the next one is ACC. A, first base A, second base, look at this column C, and the third base is also C. We move to this row C. ACC also form threonine. ACC form threonine. So the first 4 amino acids that encoded by this gene XYZ is serine, alanine, threonine, and last one is also threonine. And this is a polypeptide chains. That's all from me.
Assalamualaikum, my name is IFFAH and I will present on the last question, which is question F. Question F asks to draw the first 4 polypeptide sequence of protein XYZ and label all the bonds between the amino acids. Indicate the N and C terminus. From the previous question, we already identified the first 4 polypeptide sequence of protein XYZ, which are serine, alanine, threonine. The polypeptide sequence is drawn from N terminus to C terminus, where NH2 indicates the N terminus, while C double bond O OH is the C terminus. The 4 amino acids is connected together by peptide bonds that is formed between carbon and nitrogen.
That's all from us. Thank you.